Very well. So recording has started. Okay. Again, I'll go back to last lecture, last class, and I'll go through it a little bit fast because we've already covered it all, but just to emphasize, because it's a very important thing. So last lecture we discussed the while, and again I'm going to repeat it just to be ready for the rest of the discussion. Let me just fix the. All right. So while loop. Okay. As we say, this is in control or in when you have some process that's repeated more than once, several times. Sometimes you know the numbers, sometimes you don't know the numbers. You can use while. And we say in Arabic, while means. I don't know what's wrong with this. 1 second, please. Just let me fix it. All right. So in Arabic, while means talama. So while some condition is true, it will repeat doing the things here between the braces. All right. And this is very clear in this. If you can see this one here, when it enters the while, here we have condition. All right. So if the condition is true, it will execute this part. Okay, a block means a lot, several instructions starting from 1 to unlimited number. All right, so it will execute this code block, then it will go back and check the condition and do it again and again until the condition becomes false. When the condition becomes false, it will skip the execution of the code and goes to the rest of the program. All right. As I remember, we took this example, right? Program that reads and prints integers continuously. The program stops execution when the user enter -99, and this was the program. Okay, include here while the condition. If we go back there, it means here. I'll define any integer, for example, a, give it arbitrary value, and is not equal to minus 99, because if it's equal to minus 99, then it will skip the execution from the first step. Then a, give it 0, for example. Here the condition if a is not equal minus 99. A is equal to 0. Here, A not equal, then it's true. It will print it here and read. It will read, of course, not read, see out. Read an integer and print it. Print the integer and go back and check again. For example, in the first iteration, you gave 2, then it will print 2 and go back again. Asks you to enter another number. Maybe you enter -7. It will print -7 and go again. If you want to stop, in this case, you just enter -99. When you enter -99, you'll go there. It will find the condition is false. Then it will go out and write any message, in this case, end of program. All right, so let's see here. While n is not equal to -99, so n is equal to 0. When it comes here, the condition is true because 0 is not equal to 99, -99. All right, then it will ask you to enter an integer. It will read the integer, print it, and go back where? Here again, and check the condition. For the first time, you enter -2. It will come here and check n is equal to -99 and not equal to -99. -2 is not equal to -99. So that the condition is true. It will continue and do it again. If you want to stop, just enter -99 here. It will print it and go back there. It will find that this condition is false. Then it will skip everything and comes to this instruction, which is end of execution. What I ask you to do is to write a program that reads a real number continuously and prints them to the screen. The program stops when the user enters -1. I got a lot of answers, and I replied to most of them. So here we'll do the same. Okay. As you wrote integer n, then while of 0, while n not equal -0.1, I think in the question, right? Yeah, -0.1. So while this is true, cout enter a number, semicolon, cnn. All right, and cout n and end line. All right, then I should close this and I'll execute it. For sure, I think I'll get error. All right, I didn't get error. Then now I'll get error. Okay. See, it went to an infinite loop. Then I stop it. I told you for all those who asked what was the error in their program is this. We asked you to read a real number, right? So real number cannot be integer. So in this case, you have to change it to float or double. All right, this is the mistake that you committed when you solved this question. 1 second, stop. N not equal cnn cout. All right. While n cout enter a number, cnn and cout. I think still execute the previous one. Okay, if we check, remove this. Let me just refresh this one. I think there's a problem with the compiler. 1 second. Okay, so let's get back to our discussion. There was a problem with the compiler. Then I will run this again. All right. So it's the same thing. See, now here, if you go back and to our previous discussion, we consider integer, then I'll enter, for example, 0.1. It will go again. Sorry. 0.1. Okay. 0.1. See, we got the same error. Why? Because we defined it as integer. And I think we will keep having the same error even. All right, then let's run it again. I think there's a problem with the compiler now. All right, so 0.2. All right, it works perfectly now. 0.2, enter a number, 0.3 or 0.3. So there's no problem. The main problem was in the declaration when I defined n as integer and I entered real value, it didn't accept it. Then, for example, 2.3, 2.4. Okay, now if I want to stop minus 0.1. All right, that's it. End of execution. So this is the answer of the question. Today we'll talk about, by the way, here we have warning. Let's see. And see, this is the difference between error and warning. I told you warning is something that you need to take care of, but you don't need to worry about them. The program will be executed. What this warning says, n is used and initialized in this function. Why? Because I didn't give any initial value to n, so it took a random value from the memory. So if I want to remove this warning, I will write enter equals 0. Equals 0. Then see the warning has been vanished. Okay. This is one of the things when we explain the difference between warnings and errors. Okay, so let's remove everything and start. Just I want to make sure that the compiler is working perfectly. Yeah, all right. Today we'll talk about, or we'll discuss for loop. The for loop is a bit similar to while, but it's a bit easier. So the for loop, this is the block diagram of the for loop. First, I need to initialize. Okay, initialize the loop. For example, I will define CNT. Usually, I use this stands for counter. Initialized equals 0. Okay, then here the condition. I will put like CNT less than or greater than, less than 5. Okay. Now, is 0 CNT 0 less than 5 is true. Then it'll come here. It'll come here. For example, here's C out CNT. It will print 5. Update. This is very important thing. Here I have to update CNT. Otherwise, I'll go into an infinite loop and I will get unstable system. So here you need to update it. For example, CNT equals CNT plus 1. All right. Then now CNT was 0. After the execution of this, it became 1. It will go back again here. CNT less than 5. 1 less than 5. True. Then it will come here and print it, and it will print. Sorry, here it prints 0. Then here 1. Update CNT plus 1. Now the value is 2, and it will go again. Of course, until it reaches 5 here in the update, it reaches 5. When it comes here, it will check that CNT less than 5 is false. Then it will go skip and go there. Execute the rest of the program. All right. So here I need to mainly you need to think about three things: initial value, which is called the initialization, the update, how to update the counter, and the stop criteria, when and where to stop. All right. So in any counter, you need to think about these three things. Let's see the format, how to write it. Now, for loop is written like this: for initialization, in our case, for example, CNT equals 0. Stop criteria, which is CNT became greater than. By the way, the opposite, the condition should be true. All right. CNT is less than 5. Update CNT equals CNT plus 1. All right. This can be written like this. Of course, here I used the variable I, which is very commonly used. There's no meaning for I, but I think it came from index. Most of the loops we are using I. Why I? Nobody knows, and nobody cares. This is a tradition or a convention. So for I equals 0, I mean, I'll start from 0. I plus plus the update, every iteration I will be increased by 1. Then I less than or equal 5. This is the condition that whenever this condition is true, the execution will continue. All right. So example, write program that reads 10 integer. Oh, before that, let's write this program. I will write program that prints here. I'll put it write program that prints the numbers from 3 to 19. All right, with increment of 2 or of 1. And I'll make it easier from 0 to 5. Let's execute that program. Here, what you want to do, just start writing for I. You cannot use I unless you declare it. It's an integer. Integer I equals 0, initial value. I less than. Now, it's very important to know that to 5, when I write 2, it means 5 include. 5 is not included. When I write through 5, that means 5 is included. So 5 is not included here. When I write 2, 5, that means I less than 5, I plus plus. All right. Then C out I. And I think we can write them next to each other. I'll add \t. Okay, and semicolon. That's it. I have to close this one, and I'll execute it. See what we've got here: 0, 1, 2, 3, 4, 2, 5. Remember that because I've written 2, 5. If I say through 5, you put less than or equal. So this is the first example using the for loop. All right, I'll put it in the lecture so you can use it. As I told you, the system is a bit slow. I'll put it in the slides here. Also, I'll change this one. Example. This is the program. So let's answer the next question. Next question is, or says, write a program that reads 10 integers. So let's think about it. This program will read 10 integers and print them. That means the first thing you want to think about is the for loop. That means for integer I equals 0, 10 means I have to stop at 9, right? So I less than 10, okay, and I plus plus. Inside, I'll write cout, enter an integer, and here cin. I have to declare variable integer x, okay, cin x, cout x, ndl, okay, and that's it. Now, what it'll do, it will repeat this code, it will repeat this 10 times. All right. To make sure, I will add the counter or the number to the message here. All right, so let's write it. Remember that we want to read 10 integers. I don't think we have the answer here, so I'll write it here. I will remove this part. For integer I equals 0, I less than 10. We are talking about 10. Cout. I'll change the message. Enter the integer number, then I close it. I, and here I'll add the quotation. Okay. So I'll give a message, enter an integer number I. Why I've added this? Just to tell the user where he is now. 0, 1, 2, 3, 4, etc. Here also cn. Remember that there's an error here. cnx, but x is not declared. So whenever you use it, go there and declare x. But this should be also before or outside the loop. To avoid keep declaring it every time. All right, cout message. You have entered x, ndl, and that's it. Let's try executing it. See here, number 0, but usually we count from 1. So I think I'll do a very minor modification, +1. This is just for the message. So I'll run it. Enter number 1. Okay. And also here I'll add the colon. So the message will be very clear. Enter the integer number 1, 3. You have entered 3. Enter integer number 2. Enter integer number 5. Okay. I'll continue. 7. Okay. Again, 9, 4. See, this is the last one. 2, and that's it. Execution stops. So you can put any message. Of course, the message, although it's very important to me, but this is for the user. It's not the core of the program. So I'll add this to your lecture. And again, by the way, intentionally, I put them as images or pictures because I want you to write the program yourself. All right? Not to copy and paste. Okay, so this is the answer. All right, next, let's see. Counters. Now, the most important application or use of the for loop and the while also is the counters. The counters, it means something that counts from initial value to the final value. So here also, in each counter, you should specify the following: initial value, stop criteria, and the update. Now, let's see here. I have two kinds of counters. The counts that counts, for example, 0, 3, 5, 7, until 19, for example. If you can see this is called bottom up. It means from the lowest value to the highest value. Okay. So the initial value here is 0. Okay. The final value is 19. Who tells me what's the update here? Here the counter or CNT or I equals 0. Okay. I will stop when I greater than 19. Okay. Now here I need to see the update. How to find the update? The update is the difference between the counts here, or not the difference, the relationship between the counts. Now 0, 3 becomes 5. That means with every iteration I add 2, right? Start from, no, not correct. If it starts from 1, all right? In every iteration I add 2. 1 became 3, 3 became 5, 5 became 7. That means in every iteration. And by the way, in all the questions, the sequence is well organized or well developed, well planned, so that you can find the relationship easily. Sometimes plus 2, sometimes plus 3, sometimes multiplied by 2. We'll take example like this. All right. So here, this is what you call the bottom-up counter. Bottom-up counter are the counters that starts with the small initial value. It's not necessary to be small. It's better to say the smaller. All right, because maybe I will start from 3,000. All right, to 3,010. This is not small, but this is the smaller value. All right, I'll correct it later. So it starts from the smaller value and reaches the larger value. So and increase to reach the larger or a larger limit. And the update is increment. We have increment and decrement. Remember, it means that the counter keeps increasing until it reaches the target or the limit. For example, for the counter counts from 10 to 21. That means I'll start 10 with a step of 1. Here I've given you the update. 10, 11, 12, 13, until reaching 21. So the initial value is 10. The criteria is when the counter, stop criteria, greater than 21. Why not greater than or equal? Because 21 is included here. Although it's written 2, I think it's better to unify it. Okay, 21 is here. Update is increment counter by 1. So if we want to write this code, let us write it. Here, I will change it through. Okay. Through means this word. Through means 21 is included. Okay. So here, what I'll do. Integer equals. Initial value is 10. So equals 10. I less than 22. Why 22? Because I've written through, or 21, but I have to put equal here also. All right, I plus plus because it, the increment is 1. Then I'll print, no need to write this, C out I. \t. Total count 10, 11, etc. 10, 11, 12, 13, 14, 15, 16, etc. 21 is included here. Why included? See, I got a warning also here. The warning is unused variable. That means the program can work, but you don't need this variable. All right. Here, what we need to focus. So for integer I equal 10 to 21, I plus plus C out I, and of course, if I change this also to less than 22, all right, I'll get the same result, 21. But remember here, it's written 10 through. Okay? Through 22. If I say to 22, that means you have to stop. Okay, I will create another one just to compare the difference here. Sorry, to through 21. To 21. Okay. Here I need just to see out E and DL to start a new line. Then see the difference here less than 21. Okay, this is the difference between through. It means 21 included. To 21 is not included. If you can see the execution now. So the second one stops at 20. Remember this, please. All right. I'll share this with you now. With execution. All right. Okay. Let's see the other one. Top down. It means start from larger value. Okay. Start with larger initial value and stop and decrease to reach a smaller limit. So that's for example, if I start from 21 to 10, in this case, the update will be decrease. 21, 20, etc. Okay, 19 until reach. In this case, the initial value, for example, this counter 123 to 1 and the rest of the values is given to find the update. So in this case, start from 123. The stop criteria when the counter less than 1, all right, and not necessary to see 1 at the end, because the decrement by 3, 123, 120, 117, that means every iteration the number is decreased by 3. So the update is decreasing the counter by 3. I don't know if we didn't write it here. And focus on an important thing here. If I go to the program to write it to you. Okay. Here, if you can see from 123, that means the initial value is 123. I don't want this. Okay, from 123. It stops at 1, right? The update is I minus equal 3. It means I equals I minus 3. Now, if I execute this, I will go through infinite loop. Why is that? Let's execute it. I got nothing, right? Why? Because here the condition is different. I should consider I greater than 1. It means execute as long as I is greater than 1. In this case, yeah, we are capable to count, but it's very long, so I'll instead of \T, I'll put comma and space. Still very long. All right. 123, 120, and it reached 3 and stopped. Okay. You can see the last one is 3, or you can also put \n. All right. If you can see this is the counter: 123, 120, 117, 114 until it reached 3. So as long as greater than 1, remember in the previous one this condition was less than, because every time I'm decreasing this is not 10 through. I don't want this. All right. So I minus equal 3. Let's see more examples. I'll just share this with you. Okay. All right, let's see another thing. This part will be covered in the next lecture. Let's give you some more examples. Okay, so example. Write a counter or a program that counts the following sequence: 2, 4, 8, continues till 24. All right. Now this is your. I'll stop recording now because I want you to participate and to give me your answers. To feel free to answer this question and discuss with me. Okay, go ahead.